sine, cosine, and tangent, then we've really got it, because the others are just the reciprocals. Now, when we apply this, we are going to be looking, first of all, it has to be a right triangle. So the trig functions only apply to right triangles. So we have to have a 90-degree angle. We have to view it from one of the two acute angles. Can anybody think of why I could not use SOHCAHTOA from angle C?
Because then you have two adjacent, no opposite.
Exactly. Both of these are adjacent. This side would be opposite, but it's the hypotenuse. So your hypotenuse and opposite become the same side. We don't have one adjacent, so it doesn't work. The whole thing falls apart. So SOHCAHTOA only applies to those acute angles. Now, I've told you that when you put sine or cosine or tangent, you have to have an angle. Leaving it off is like putting a square, but not what you're squaring. You have to give me that angle. Because it's different if I talk about sine from angle A versus sine from angle B. What would change if I flip my angle? The opposite and adjacent sides. The hypotenuse is always the hypotenuse because it's across from the right angle. But if I'm here at angle A, my opposite side is down at the bottom. But if I'm at angle B, my opposite side is this vertical side. Just a naming thing. If you remember in geometry with triangles, typically they use capital letters for angles and lowercase letters for sides. Side A is across from angle A. Side B is across from angle B, and side C is across from angle C. So a lot of problems, we might read a problem and it might tell us some information. You want to make sure you're putting it the correct spot in your triangles. So we need to know how that's labeled. So let's talk about it. From angle A, which one is my opposite side? Side A. Which one's the hypotenuse? C. Hypotenuse is always your longest side across from the right angle. So that means B is our adjacent side. Alright, so let's fill in the definitions. Sine of A. So from angle A, sine is opposite over hypotenuse, so that would be A over C. So that means cosecant is okay, cosine from angle A. Cosine is adjacent over hypotenuse, so that's B over C, which means secant is C over B. Tangent, TOA, is opposite over adjacent, so A over B, and then cotangent would be B over A. So far, so good? Let's look at the problem. So we have triangle ABC. It's a right triangle with angle C equal to 90 degrees. So let's draw the picture. So C is our right angle. Okay, this is where people make a mistake on these problems, is labeling your side information. So when I say side A is 6, that's across from angle A. Side C is 10, so that's the hypotenuse. Find the 6 trig functions of angle A. Alright, what am I going to have to do here? Right, I don't have all 3 sides, and we need that. So we're going to do a squared plus b squared equals c squared to start us off. So 6 squared plus b squared equals 10 squared. So b squared equals 64. Now we need to do a square root, and we've talked a lot about looking at quadrants to decide if things are positive or negative. If I'm drawing a triangle though, can you draw a triangle with a negative side? No. So this is an automatic positive. So that's one perk of the triangles. It's got to be a positive measure. Alright, so what would be the sine of A? So we are viewing from angle A. So the opposite side is hypotenuse 10. I do not want decimals, but I do want them in lowest terms. So 6/10 reduces to 3/5. And then we automatically know that cosecant is 5/3. Okay. Cosine is adjacent over hypotenuse. So the adjacent side is, and hypotenuse is 10. So 8/10 reduces to 4/5, which means secant is 5/4. And then tangent, TOA, opposite over adjacent, would be 6/8, which reduces to 3/4. So cotangent is 4/3. I want you guys to do example 2. I'm talking about the same triangle, but I want you to give me all the ratios from angle B. So the only thing that changed, same triangle, same side, but you're viewing from angle B. So what did sine turn out to be? 4/5. It was opposite over hypotenuse, so 8/10 was 4/5. So cosecant was 5/4. Cosine is 6/10, which is 3/5. So secant is 5/3. Tangent, opposite over adjacent, so 8/6 is 4/3, and cotangent is 3/4. Okay, here's why I did this. You look, sine of angle A is equal to what in the second one? Cosine of B. Tangent of angle A is equal to what? Cotangent of angle B. Cosecant of angle A is equal to secant of angle B. And vice versa. Cosine of A is equal to sine of B. Cotangent of A is equal to tangent of B. Secant of A is equal to cosecant of B. How are angles A and B related? I mean, they're two angles in a right triangle. What would be true about the measurements of A and B?
They're equal.
Sometimes. If angle A is 20 degrees, what would angle B be equal to? 70. Why? We know a triangle adds up to 180. Angle C is 90. So angles A and B have to add up to 90. So A and B are complementary angles. And so it turns out there is a special relationship called cofunctions. So the cofunctions, sine goes with cosine, secant goes with cosecant, tangent goes with cotangent. Okay, this is different than reciprocals. You notice the co-function just put co in front of the word. Cofunctions are equal when the angles are complementary. So what that means is if I said sine of 35 degrees would have to equal what? the cosine of 55 degrees, because sine and cosine are cofunctions. They will be equal when those angles add up to 90. Okay, this isn't a difficult property. It is one that people tend to forget, just because it doesn't come up a lot, but it can save you a lot of time if you remember that. So let's do example 3. Solve for theta. Theta is just any other variable. Trig likes Greek letters, so you're going to see alpha and beta and theta, so don't let that scare you. So I want to find theta if secant of 5 theta plus 14 equals cosecant of 2 theta minus 8. What do you know about secant and cosecant? They're cofunctions. So they're equal when what's true? When angles add up to 90.
So now we treat theta kind of like a variable?
It's just like an x or anything like that. So if we add like terms, so in theta, 84, and theta is 12. Any questions on that one? Okay. So the next piece that I want to get into, it turns out in trig there are certain angles that we are going to see all the time. We've already talked about some of them on our last test, those quadrantal angles, the 0, 90, 180, 270. Those are some that come up frequently, and we were able to figure out all of our trig functions there. They turned out to be nice numbers, 0, 1, -1, undefined, things we can easily calculate. In general, your trig functions are not going to be pretty answers. A lot of times they're going to be nasty decimals or radicals, but there are certain ones that are very, very common and actually do work out nicely. The first of those is a 30-degree angle. So I kind of jumped ahead. I gave us a 30, 60, 90 triangle, and I gave you the side lengths. If anyone is interested in how to get those side lengths, I'd happily give a little geometry lesson if you want to know how I knew it was a 1 radical 3 and 2. No takers, nobody cares. You guys are no fun.
Oh my gosh, how did you do it?
Oh, thanks. Let me show you. Okay. So if you started with an equilateral triangle. Okay, so let's just say every side is 2. So if all the sides are the same, all the angles are the same, right? So what does each angle have to measure?
60.
Okay. But we know trig functions only work in what kind of triangle? Oh, right. So if I had to make a right triangle, I could drop a perpendicular and split this in half. So now, this is 60, and that's 2. That was 60 degrees, so half of 60 is 30, and that's a right angle. Okay, this whole side was 2, so half of it is 1, and how would I get this other one? Diagonally down. So A is radical 3, and that's where I got this magical triangle. So thank you for asking, Emily. I'm really glad you wanted to know. Okay, so let's do our 6 trig functions for 30 degrees. So from my 30-degree angle, sine is opposite over hypotenuse, so that would be 1/2. So cosecant is 2. Okay, cosine of 30. So cosine is adjacent over hypotenuse, so that would be. So secant, when you flip that, you get 2 over radical 3. Can we leave a radical on the bottom?
No.
Should be 2 out of 3.
Okay, tangent of 30, opposite over adjacent. What would that be?
Radical 3 over 3.
Right, you get 1 over radical 3, but when you get the radical off the bottom, radical 3 over 3. So cotangent of 30, just plain radical 3. Alright, so far so good? The second common angle is actually 60 degrees. I'm not going to write all these down, but we could talk through them. So what is the sine of 60? Over 2, which is equal to the cosine of 30 because they're cofunctions. So the cosine of 60 is the same as the sine of 30. It's 1/2. Tangent of 60 would be opposite over adjacent, so radical 3 over 1, or radical 3. Okay. The third and last common angle we have is 45 degrees. So let's create our triangle. We know we have to have a right triangle. So if one of these angles is 45, what's the other one?
45.
And if those angles are the same, what's true about these sides? They're the same. So we could pick anything. Let's just do 1. So to find our hypotenuse, so we get the square root of 2. Okay. So the sine of 45. Doesn't matter which 45 angle you choose to look from, you're going to get the same thing. So I'll just go from the bottom. So opposite is 1. Hypotenuse is radical 2. So that would turn into, not radical 2 over c. I don't know where the c came from there. Okay. I just did sine of 45. You could pick either one. I'm doing from down there. Okay, so that means cosecant, reciprocal of sine, would be
Oh, not that one.
square root of 2. What is the cosine of 45? Same thing, adjacent over hypotenuse, which is radical 2 over 2. And that means secant is also radical 2. What is the tangent? Opposite over adjacent, 1 over 1, which is 1. So cotangent is 1. Alright. You like the 45s? So here's the deal. These are very, very common angles. We are going to see them all the time, so we really have to memorize their values. Now, I know, I just say that and everybody's like, ooh, that's a lot to memorize. And it is, but I have tricks for you. Okay? So you'll notice, I'm going to give you a handout. It's got the same table that's on your notes next. What I want to do is, on this handout, let's use the hand on the top, and we'll use the table that's on the first note sheet I gave you. Tomorrow, we're going to practice it again, so we'll use another one of these. And the next day, we'll probably practice it again, and the next day, we'll practice it again. So I'm giving us just a bunch of tables so we can keep practicing these. Okay. So I want to preface this. I prefer, there are lots of tricks out there. I prefer this one. It's my favorite, the hand trick. If it does not make sense to you, you have to tell me. There are other tricks I can give you, but this is the one that the majority of people it usually works for. And I found if I just start listing too many tricks out here, I just confuse everybody. Okay, so I'm going to do this one. Then if you don't like it, tell me, and I can show you other ones individually until we find something that works for you, okay? So what I want you to do first, we have a pattern for how we are going to find sine, cosine, and tangent. And this pattern, you really just have to know this part for the hand trick to work. Sine is going to be the square root of something over 2. Cosine is going to be the square root of something over 2. And tangent is going to be square root over a square root. Now you'll notice on the table, I have 5 common angles. 30, 45, and 60 are the ones we just talked about. 0 and 90 were 2 quadrantal angles that we had in the last test. We are going to label our fingers as those common angles. So we have our 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So what I want to do is just start filling out the table, and I'm going to show you as we do this how the hand trick gives us these values. So at this point, we've talked about all of these before. The 0 and 90, we were drawing that diagram with the 0, 1, 1, 0, those points. 30, 45, and 60, you could go back in your notes and write all those down right now. What we're going to do, when I say sine of 0 degrees, you're going to fold in your 0 degree finger. So you're folding in your thumb. Sine and cosine, I told you both of those are square root over 2. Sine is the top, cosine is the bottom. So what I mean by that, when I fold in my 0, sine is the top. How many fingers do we have above the one we folded in? None. So it's the square root of 0 over 2, which is 0. So sine of 0 is 0. Okay, if I wanted cosine of 0, so my 0 is folded in, cosine is the bottom. So how many fingers are below what I folded in? 4. So the square root of 4 divided by 2. So square root of 4 is 2, divided by 2 is 1. Everybody with me here?
Yep.
Okay. Tangent is square root over square root. Square root of the top divided by square root of the bottom. So I have no fingers above and 4 below. So 0 divided by 2 is 0. I'm just going to do sine, cosine, and tangent for a minute. We'll come back to the others. Okay? So at 30 degrees, everybody hold in your 30 degrees. So sine, how many fingers do you have above that? 1. So the square root of 1 is 1 divided by 2. So we get 1/2. Cosine. So how many fingers are below that? 3. So that's the square root of 3 divided by 2. Tangent. Square root of the top divided by square root of the bottom. Can you leave a radical on the bottom? No. So if you multiplied that radical 3, you would get radical 3 over 3. Does that match the examples that we've worked out so far? We got sine of 30 to be 1/2, cosine of 30 to be radical 3 over 2, tangent to be radical 3 over 3. Okay, so 45. You fold in your 45. So what's sine?
Radical 2 over 2.
You have 2 fingers above that. So the square root of 2 divided by 2.
And then cosine is the same.
Cosine, we have 2 fingers below, so square root of 2 divided by 2. So tangent is the square root of 2 divided by the square root of 2, which is 1.
Wait. Sine is on the top, cosine is on the bottom?
And tangent is sine over cosine, so that's why we do really the square root of the top divided by the square root of the bottom. Okay, so at 60, fold in our 60, what's sine? Cosine. Radical 1 over 2, so that's 1/2. Tangent is radical 3 over radical 1.
You can't make that. Oh.
Just leave it as square 3. Okay, 90. My pinky won't fold in, so I have to hold my pinky. How many fingers do we have above it? So square root of 4 is 2, divided by 2 is 1. How many fingers are below it? So square root of 0 divided by 2 is tangent. Square root of 4 divided by the square root of 0. Undefined. Can't have 0 on the bottom. Okay. So this hand trick gives us sine, cosine, and tangent. Does everybody understand how I got these values? So how does that help me get the others? Just flip them. They're reciprocals, right? So cosecant is the reciprocal of sine. What is the reciprocal of 0?
0.
Yeah. 0 is like 0 over 1. So when you flip it, it's 1 over 0, which is undefined. Okay. Reciprocal of 1/2?
2.
Oh, we can't cross.
Yeah, we're just flipping, so 2 over 1. Okay. For 45, if I flip this, so I get 2 over the square root of 2. If you multiply by radical 2 on top of them, you get 2 radical 2 over 2, which is just the square root of 2. 60. If we flip this, then you have to get the radical off the bottom, so you get 2 radical 3 over 3. 90, reciprocal of 1 is 1. Okay. Secant is the reciprocal of cosine. So reciprocal of 1 is 1. We have 2 over radical 3. That turns into 2 radical 3 over 3. 2 over the square root of 2. That's 2 radical 2 over 2, which is just the square root of 2. If I flip 1/2, we get 2, and then what's the reciprocal of 0? Alright, cotangent is the reciprocal of tangent. So reciprocal of 0, undefined. If I did the reciprocal of this, I have radical 3 over 1, so radical 3. Reciprocal of 1 is 1. If I flip that one, I get 1 over radical 3, so radical 3 over 3. And what's the reciprocal of undefined? 0. Okay. Everybody with me? Does anyone see any other patterns here? What do we know about sine and cosine? They're cofunctions, so they're equal when their angles are complementary, right?
0 and 90.
So 0 and 90 are complements. 30 and 60 are complements. 45 and 45 are complements. 60 and 30, 90 and 1. If you have sine, cosine is the same thing in reverse. 0 and 1/2, radical 2 over 2, radical 3 over 2, and 1. Do you guys see that? What's the cofunction for tangent? So tangent and cotangent are the exact same things, just in reverse. And the reciprocal of cosecant is secant. So they are the same things in reverse. Do you guys get what I mean?
Yes.
So what that tells me is I probably did more work than I had to trying to figure this out, because really, if I had tangent already, I could just start here and write down all the same values from the other side. And we get this. So you really only have to figure out a few of them, and cofunctions give you the rest. Okay, so we are going to be practicing this a lot more. There's lots of patterns here, so we will be working on that. Are there any questions on how I got these values today? So what I would like to do, let's go ahead and do the next example, and then we'll probably have to stop for today. Oh, that's not what I meant. So
Wait, are we still on our paper or not?
it's on the paper. I just failed to. So the first one, we had 2 cosine of 30 degrees. Everybody with me there? Okay. What is the cosine of 30 degrees? Let's try not to look at the table. Let's use our hand trick. So if we fold in our 30, cosine is the square root of the bottom over 2. Radical 3 over 2. 2's cancel, and we get radical 3. I do want to warn you, I'm going to require exact values on all of these. Meaning if you type it in your calculator and you get the 1.7 decimal for that, I will count it wrong. Because I want the answers that we are learning. So yeah, I want the radicals, not what your calculator gives you. Alright. Second one, we have the tangent of 45 degrees plus the tangent of 60 degrees squared. So, start in the middle. So, tangent of 45. Fold in, that's radical 2 over radical 2, which is 1. The tangent of 60. So, if we fold in the 60, that's radical 3 over radical 1. Radical 3. What does that square mean?
Square root of 10.
Yeah, so I'm going to write it twice and FOIL. So 1 times 1 is 1, plus 1 radical 3, plus 1 radical 3, plus, what's radical 3 times radical 3? The square root of 9. Square root of 9 is 3, plus 1 is 4. 1 radical 3 plus 1 radical 3 is 2 radical 3. Last one.
This one's long.
Okay. When you see this sine squared of 45, that means you take the sine of 45 degrees and then square your answer. So at 45, sine is the square root of the top over 2. So radical 2 over 2. Minus 2. Sine of 45, we just said, was radical 2 over 2. Cosine of 45 is? Same thing. Cosine squared 45, so cosine 45 is radical 2 over 2 squared. Okay, so when we square this, you're getting the square root of 4 over 4. Square root of 4 is 2, divided by 4 is 1/2. Okay, if you multiply those, square root of 4 is 2, divided by 4 is 1/2. Plus, again, radical 2 over 2 squared, so radical 4 over 4 is another 1/2. So 1/2 plus 1/2 is 1, 2 times 1/2 is 1, and we get 0. Questions? Bring back some algebra. So, we are very, very close to done. I have 2 examples left. So tomorrow, first thing, we will practice filling out this table again on one of your numerous other copies of it. We'll do the last few examples, and you will have some class time to work on homework tomorrow. I am going to go ahead and give it to you, though. You have a little time.